And then, like I say, resin uses liquid resin. They use UV light cure. And then once it actually appears to look like, you take it off and it's done burning, and you actually need to set it in the sun or a UV curing chamber to truly finish it.
Where that?
I got a microphone.
Yeah.
Hello, microphone.
So really, it's running everything.
Here's a good view of either this or a resin printer. So resin printers print upside down. It dips because it's a liquid. You can't just toss liquid on the plate and hope something happens. So the UV light is under this purple stuff, and it dips in and out. And the UV light is it uses a sequence of mirrors and whatnot, so it can cure it in a very specific area, which is how you get these complex geometric patterns. But our FDM type printers use a bed that moves back and forth. This is technically a bed. And a nozzle, otherwise known as a hot end, that moves back and forth. And the filament goes into an extruder, and the bed normally gets hot. There are cold type 3D printers. Those aren't very common. They're difficult to use. And the hot end gets hot, and it puts out molten plastic that then cures itself through a printer actually adds compression to each layer. And so even though the nozzle most nozzles are 0.4 millimeters, the layers are only actually 0.2 millimeters tall because it adds that compression if you have your stuff calibrated right. That's how you can get different qualities even though they're still printing correctly. Here's some of the filaments we use. So most stuff is going to be made out of PLA, especially when starting. So PLA is actually biodegradable. It's not actually plastic. It stands for polylactic acid, which doesn't matter because it doesn't tell you it's biodegradable. It's brittle in comparison to most of these and not very flexible. It's a solid. ABS is oil-based, so it's an actual plastic. It's a little bit more expensive, and it's stronger, and it looks like, if you've ever bent a piece of plastic, how it gets white, that's what happens with ABS. PLA just snaps. PETG is also oil-based, but it collects humidity really quickly, and a little bit more expensive than ABS and less popular because it's ABS, except more food safe, in quotes, and that's why it's more expensive, so just no one uses it. TPU is a flexible substance, so you can use different infills and patterns and walls, which walls are the outside of the print, that will give it different flexibilities. So some, if you print at like upwards of 80 to 100% infill, it will just be like PLA. It's just a brick. But if you print down to like 10%, you can squish so much at so much time, and it's so fun. Onyx is what we use for the Mark Forge, so that's really expensive, and it contains chopped carbon fiber. So carbon fiber is about the strength of aluminum, and this is kept in a very expensive dry box because it collects humidity incredibly quickly, and humidity breaks filament. It will break the printer or break the filament, or both, because the printer will break and it will try and keep going and then just snaps filament. And then we can infuse Onyx with carbon fiber, inlaid solid carbon fiber, and that is also very expensive. It comes on a tiny little spool. So don't misuse either of these because we like money and we don't like losing money. Different types of resin filament. We don't really have a resin printer, so there's some that are food safe. Most resin is water resistant. There's flexible types. There's standards. There's clears. There's ceramic, so it's going to be really solid. Now we get into some of the printers we own, and I didn't put the X-Max on here, I don't think, because we didn't have it last year, and I haven't used it, so I have no clue how it works. The build volume on this is 220 by 220 by 250, and when we're talking about printers, we're talking in metric because everything comes from China. Okay, it's a single nozzle, so some can have multiple extruders or a extruder system, even though it might have a single nozzle. The nozzle size is 0.4, like everything else. the max nozzle temp is 240 Celsius and the max bed temp is 130. So if either of those go above what they're supposed to, it will try and cool it back down, but eventually you're going to blow a fuse or blow a thermal fuse. So it's just like our robot where we keep talking about how if you put too much power in, the fuse goes near. And it's an FDM type, so you have a spool up here that feeds down into the head and then melts it. Mark Forged. So this is our carbon fiber printer. This is the one that is an expensive printer that uses expensive stuff. It can do 320 by 132 by 154. It's dual nozzle, so one is for this little tiny spool of carbon fiber that you can inlay, and one is for the Onyx. It's a 0.4 millimeter nozzle size for the Onyx, and the carbon fiber is a very special type of nozzle, so it's not something that you can change. The max nozzle temp is 300 Celsius for the Onyx. I couldn't ever find the max bed temp, even after 2 years. It's just not out there. It can infuse carbon fiber into the parts to make them even stronger. So we're making aluminum grade parts off a 3D printer, which is really cool. It can print at 280 millimeters a second, which is kind of insane. That's a really good speed. And then it's an FDM type and it uses Onyx. Oh, hey, I did do it. Its build volume is 300 by 250 by 300. It's sort of dual nozzle. It says online that's dual nozzle, but that's not right. It has swappable nozzles for different things. I think one's hotter, right? You should know this. One of them's hotter.
I haven't swapped it before.
Oh, okay. The max nozzle temp is 300 and the max bed temp is 200, or 120, not 200. 200 would be bad. It can print at only 150 millimeters a second because it's bad. And it's an FDM type printer, which it has an enclosure too, so it can do parts better, and it's direct drive, which is something I should have added to all these. So it can print types like TPU, because TPU is really flexible and it will get caught up in a Bowden tube, which is what the filament passes through.
Yeah.
This is the same brand as this. So it's an Ender, which is almost the most common type of 3D printer. It's slowly again taking over because there's better grade 3D printers that don't come from China for averagely the same price. So vendors like Prusa from the Czech Republic and a couple others are starting to take over the marketplace in comparison to Creality. So it can do 220 by 220 by 250. It's single nozzle. Nozzle size is 4.4 millimeters. It can do 260 Celsius for nozzle temp and 100 Celsius for bed temp. It can print at 200 millimeters a second, and it's an FDM type printer. This is one of our newest additions, and this is a cool one. It's 200, this is our print mill, so it prints infinitely. So it's 200 by 170 by infinity. You can print anything for as many times as you want or for as long as you want. So you could print something across the shop if you have the filament for it. Right now it's a 4 millimeter, which all these nozzles can be changed if we want it bigger, because filament comes in a larger size and it's compressed down. The max nozzle temp is 240, max bed temp is 100, and it can print at 250 millimeters a second. It's an FDM type printer, and like I say, it can print one thing forever or multiple forever. These I don't think we've used in like 2 years, but we have them. Yeah, 2 years ago. So these are deltas. So it's a spider-like design, but they're called deltas. So it moves the legs up and down via motors, of course. So instead of having to use a belt, it just uses a lead screw. So it's more accurate in theory and can print a lot faster. It's just, these aren't great. They're single nozzle. They're 110 by 120, so it's circular, so the height is 120 and the diameter is 110. It can do 260, and the bed temp is only 60. Max print speed is 170 and it's an FDM type. So we used to use these for TPU because they're direct drive, but I think only one of them works at all and we haven't used it.
Roman. So you gotta be careful using these ones because when they start leveling, they'll actually crash into the build plate and keep going, so they'll break themselves if you don't watch them. So, yeah.
Thus why we haven't used them.
Now the two that don't work, we can't get the bed level.
Yeah, and the one that does work, we don't trust. Anyways, most of you know what this is. Most, as in like 6 of us and Victor. So this is a printer that we have 48 of at my high school. We have one of the largest, actually we absolutely have the largest print farm for any high school ever. So we run these, depending on what we're doing, sometimes 24/7. So these are really nice. They're more expensive than Enders, but they are more manageable. They have better firmware, they use a better slicer, and they are easier to repair than Enders, but they are $200 more. But in my opinion, it's worth it. So we don't need to go through all this because we don't have one, though we should. Could you try the link? It might be blocked. Notice all the essays about walls and
Wall definition of fence.
Great title.
I think a fence is a wall. But you can partially pass through it, so it gets kind of difficult. But if it is, then
It's a gate.
yeah.
Get your terms.
The black, stop it. The black control, turn the sound bar on. You should see on this side of it, the lights go off.
Lights are off.
Yeah. You should see like 4 of them light.
I believe it.
I should have sound.
And I see the volume going up.
You is at like 30.
The volume is at 45.
Yeah.
It's not.
Now it's at max.
Stop turning up the volume.
It's not working.
Do I have,
Over and over? How does an automated milling machine move with such precision?
so this is about the motors that run accurate machines, which is 3D printers are mills.
Stepper motor is that it can control the angular position of the rotor without a closed feedback loop. It is a simple, accurate, and open loop system. Let's first understand how the variable reluctance type of stepper motor works, which is the simplest one. Later on, we will move to a highly accurate and commonly used motor type. This motor has 6 stator teeth and can be energized with 3 separate DC power sources. The rotor is made of a stack of steel laminations. It has a different number of teeth than the rotor, 4 in this case. This is done intentionally so that only one pair of rotor teeth is aligned with the stator at a time. You can explain how this stepper motor works by yourself. If you de-energize coil A and energize B, it becomes clear that the rotor will rotate as shown. From the geometry, it is clear that the one-step size is 30 degrees. To get the next step, de-energize coil B and energize C. After that, coil A becomes energized again. In short, the rotor moves to the position with the least reluctance. The step size of this motor is 30 degrees. You can improve the accuracy to 15 degrees with a small trick. When coil A is energized, the rotor is in this position. We know that when coil B is energized, it moves 30 degrees. What happens when coils A and B are energized together? The rotor will come to a position between these two cases, or it will move 15 degrees. After this, de-energize A. Then, after reaching B, energize C as well. This kind of operation is known as half-stepping. motor we have been discussing is called a variable reluctance motor. The most versatile and commonly used stepper motor is the hybrid motor type. Let's explore the functioning of a typical 1.8 degree step size hybrid motor.
So this is what most 3D printers use is 1.8, but there are some 0.9s, which is that half step he's talking about. Continue.
The hybrid motor has an axially magnetized rotor with toothed steel caps. So one end of the rotor becomes the North Pole and the other end becomes the South Pole. The accuracy of this motor lies in the clever arrangement of the rotor and stator teeth. Let's understand it first. The rotor has 50 teeth. To understand the stator teeth arrangement, first assume that the stator has 50 teeth as well. However, the stator actually has 2 fewer teeth than the rotor. So we are left with 48 teeth. Let's arrange the 48 teeth into 4 group pairs as shown. Now let's realign these groups. The green set moves so that it is half aligned with the rotor. The teeth of the yellow group are completely unaligned with the rotor teeth. The blue group is half aligned with the rotor. The red group remains in place. In short, the red set is completely aligned with the rotor, while the yellow set is unaligned. The other 2 sets are half aligned. Please remember that the rotor end facing you acts like the South Pole. The stator coils are connected as shown. They are 2 independent coil sets. When set A is energized, the stator forms a magnetized pattern as shown. One pair of stator poles act as the North Pole and the other as the South Pole. As the opposite poles attract, they will be aligned. The same polarity poles will be unaligned. When the coil B is energized, observe what happens to the rotor. It has to rotate by a small angle in order to align with the new North Pole. It is clear that this angle is 1/4 of the angular pitch. In other words, the rotor moves by 1.8 degrees. Next, set A is energized with the opposite polarity. Again, the rotor moves by 1.8 degrees. This process is repeated and a highly accurate motion is achieved by the motor. The step angle resolution can be further improved by half-stepping. It is interesting to note that the north end cap teeth are placed in between the south end teeth. This way, the alignment of the opposite polarity poles are guaranteed again. So this is how a hybrid stepper motor works. They are ideal for applications where precise movements and simple control are desired. At Learn Engineering, we are able to...
Okay, so that is how this is running right now. And as you can see, that's a whole lot faster than click, click, click. There's no ratios or anything. It is, well, there might be. I don't think so. But that's how stepper motors works. That's something kind of important and interesting to know about 3D printers and our CNC machines, because that's how you get insane accuracy down to, on our mill, at least 1,000, or no, a 10,000th. So think about a 10,000th of an inch in your head. Can't picture it but the CNC can. Continue.
I'm supposed to talk about slicers.
You want a mic,
Oh, okay.
and you should talk louder.
Alrighty. All right. When 3D printing, once we make a CAD design, the 3D printer has no idea what to do with it. So we export it as an STL file and put it into a slicing software. So the one we use is Kira, at least for the Enders, and then we have different softwares for the Markforged, and then does the XMax have a different slicing software? It does. And then what the slicing software does is it takes your CAD file and then slices it layer by layer so the printer actually knows what to move or how to move, and it gives it G-code. So it tells where the X, Y, and Z needs to be and how much to extrude at that spot. And then there's lots of different settings throughout these slicers that allow you to fine-tune what you're printing, like the infill or the wall thickness. You tell it what type of filament you're using, and really all about what you're trying to do or what you've put into the printer so it knows what it's supposed to do. Sure. And as you see, there's kind of a build plate on there. You can, the build plate right here. You select the printer you want. So Cura will have different printers you can select, which will give you the right build print size, build plate size, and then you put your part on there. It's important that you know how you orient your part on the build plate so you're not using extra supports or no supports at all. Like if you're trying to print, I don't know, the letter Y and you put it just on the tail of the Y, there's no point in that because it needs now support on either side of it, where if you just laid it down, it needs no support. So just think about that when you're doing prints. Also, the way it prints, if you want a piece to be stronger in one way or the other, depending on how you place it will depend on how those rows line up. I think I've kind of covered this, sort of. Oh, the giant slice button. Once you've told it all its settings, you hit the giant slice button and it will slice it and tell you how long it takes.
The blue thing in the corner.
This thing. Sure. And then this Creality slicer, as you can see, just goes on. So you can put what you want on it, and that will allow you to print a very long object, or mini objects. So you've seen us print the little 1720 pins, or just like those, and just line them up and whee.
So that is running off the same operating system as Cura. Creality borrowed it from Cura and then just made the build plate go on forever and added a couple options because it's a belt printer. So like, how many do you want? 100. There you go. There's now 100. It just looks like one though, instead of having to import the same thing over and over and over and over. So it runs about the same. It just depends on what you want to do with this that makes it different.
This is for the Mark Forged. I have not used this slicer. Is it pretty similar to Cura in the way it functions? Or?
They take care of a lot of the, so in Cura there are hundreds of things that you can change. You don't necessarily want to, but there are hundreds of variables that are available if you dig in, more than you want to know about. Tiger hides those from you, so they know how their printer works. Basically, you're going to give them your part, and they're going to figure out most of the settings. You're going to tell them if you want what's it called? Infill? Like if you want to lay Kevlar, or fiberglass, or carbon fiber, you actually want to lay that in there as well. It'll print the plastic part, the nylon with the chopped fiber, print that. Then it'll come back and lay a piece of carbon fiber in there and then cut it off. So you can actually put real carbon fiber, real fiberglass, real Kevlar in your part, which makes them really strong. So you tell them if you want that. You tell it basically what percentage infill you want, and you're kind of limited. They kind kind of suggest 35, but you can go to 55. Really, those are kind of the two options. When you run the ECIR, it will print a bunch of fiber just to clear the nozzle. We call it purging, because the filament that is between the nozzle and the dry box is probably moist. So they'll go ahead and print all that out until they get to the dry filament, and then they'll jump over and use your filament. We also have a camera on that one, so you can see it's so we have Wi-Fi cameras here, and we have a Wi-Fi camera on there, so I can start a part and actually look from home and see if it's messing up or not. 3D printing is a little bit of art and magic, and it works sometimes. A lot of the time it works as you get more familiar with it. But it'll surprise you in the most interesting ways. One of the most, I don't know if you mentioned it, one of the most common things that happen is you get partway into your print and the print comes loose from the build plate. So then it sticks to the head and it keeps extruding and you just get a bigger and bigger bubble on the head. And it can get really big if you don't stop it.
Or it doesn't come loose, as I think you and Carter know. I have seen ruined beds, and I have ruined a bed. When you're printing TPU, they tell you to put glue down on your nice magnetic beds because glue helps adhere for glass beds, and that's what I thought it was. So I wasn't too worried about it. It doesn't help adhere. It keeps it from bonding with the bed. So I printed a big piece of TPU, which is flexible, on a nice brand new big build sheet from one of our big expensive printers. And that build sheet is now one-sided. It used to be two because the entire other side of PI, which is the coating, came off with the part. After about 3 hours of work to even get it that far.
Did you talk about using glue?
I just did.
We can though.
Use glue on glass beds, and if you're printing TPU, use glue or ABS. Yeah.
How do you tell if it's a glass bed or not?
If you have to hit the part with a mallet to get it off, it's a glass bed.
The glue also helps it get off the bed and not also just...
Yeah. So for the glass bed, it helps it adhere to the bed and stay on, but it also makes it really easy to get off. Same with TPU and ABS on beds that don't need glue for PLA and whatnot. It helps you get off because it doesn't adhere to the bed and you don't take off the coating. So be mindful of what you're printing and how you're using the printer because bad things can happen and bad things aren't fun.
The glue we use is simply Elmer's glue stick.
Yep.
And every once in a while, it turns blue after a while. And every once in a while, you just want to take the bed out of there and wash it completely clean and start over.
And don't use copious amounts of glue. You don't need to use half a glue stick. You should cover the area that you're going to be printing, not the entire bed, but the area with 3 coatings. So I go back and forth and then sideways or perpendicular to what I just did. And that does a really good job. Next slide.
Sure. I think that's the last slide, actually.
So the ECIR, the one that's on the end cap there, that's a $20,000 printer. Now, we got it used for $10,000. One of our mentors bought it. We bought it from him. But that uses filament that costs $183 a roll. Most of the filament we buy costs $20 a roll. Okay. So you don't want to print with that until you're sure you got it right. That's why we print with PLA, because it's cheap. We keep changing the part, changing it, until we get it right, then we'll print it in a sturdier material.
But there can be variance between printing in PLA and printing with that material. So if it's a really tight tolerance, you're still moving a little bit, right?
So Mark Forge directly sells Onyx. So I guess I should go to it. I was going to look at something else with this version.
I guess just a note when 3D printing, I'm not sure how many of you guys already have experience with it. I'm guessing most of you, but it does help to not just hit start and then walk away and come back the next day and hope it's printed. So just coming back and checking that it has adhered.
Yeah, but it's still the same price.
No, cheaper. 183.
$7.
$7.
Hey.
What are you saying, Paul? Not hitting print and walking
Yeah,
away?
basically just make sure it's adhered to the build plate, and once it's done that, you have a much higher chance of it successfully printing. But if it's a home printer, it does help, and like you're there to check on it, you know, throughout the day if it's a long print, just to make sure you don't come back a day later and you just have a massive pile of just spaghetti, or you know it's sucked up all around the nozzle, and then you have to heat the nozzle up, pull off all the, you know, melted plastic, and then clean off the nozzle, which can damage it, and if it doesn't, it's just a hassle. So.
And there's different strategies for adhesion, right? If you have a piece that's very flat and has a lot of surface area with the build plate, you can in essence just print it. If you have a part that has minimal contact with the build plate, you can create what's called a raft, where it will actually just put a layer all around it that adheres, and then it sticks to your part. So your part will go and it sticks. So you really want to look at how much surface is touching the build plate. If it's not much, you may want to print with a raft versus, and there's some other options, versus just getting a skirt that just makes sure your nozzle is at the right height.
A couple things on safety too. Stuff is hot. The bed for PLA can burn you if you hold your hand there for too long. The nozzle will instantly burn you. I've had some bad burns from it. And these are low temp nozzles. When you get up to the Mark IVs and stuff, it's printing really, really hot, and it could be permanent damage to your hands. So be very mindful. Only have the nozzle on when printing, or if you're cleaning it off, use pliers. Don't just stick your hand there and try and grab the filament and drag it off, because it is hot. The filament will be hot too, so don't just stick your hand under it while it's printing, because that can burn you too. Normally that's, you know what, never mind. Sometimes it's okay, but don't do that.
Also the stepper motors, they get hot too.
Steppers can get hot. They're not, you have to be running the printer really fast to get them burning hot, and that gets into water cooling and stuff. You can water cool 3D printers, which is interesting. But the good idea is just touch the screen and touch the rest when it's done printing and has cooled down. It has, right on the front screen, there's a spot that says the temperature that the nozzle's at and what it's trying to get to, and what the bed's at and what it's trying to get to. If the bed is where it's at or on its way up, don't touch it. If the nozzle's where it's at, supposed to be at, or on its way up, don't touch it. If it's around 30 degrees Celsius, that's about room temperature, it's safe to touch for either of them. Any questions?
So I just want to reiterate the part about when you start a print, just stay there by it until you get that first or second layer on, because that's when it's going to fail. So we've had students start things just before they go home, come back the next day and it's a blob. So they didn't wait to see if it's going to stick. And it's a little bit unpredictable, so you got to just make sure it's going to stick.
How many people here have already done 3D printing or have experience with it? Okay.
And of course, if you have any questions later down the road, because just sitting at a meeting and watching me talk about it only does so much. If you are just guessing about something, we say this pretty often, just come find someone who knows what they're doing and who will help you, because we'd rather take 5 minutes to teach you something than to break something. Because breaking something takes a lot longer and a lot more money. Because asking is free. Yes, Alex?
Can I see slide 1 again?
Say what?
Slide.
Oh, yeah, of course. You laughed at it like a joke.
From it, Emma looks like she's gonna shoot you. I recommend.
You want to read my essay?
This was my entire thing.
No, it's,
Maybe not now.
Can you talk about supports?
I can talk about it some more. I mentioned it. Essentially, what supports are is if you have a print with a overhang, you can select supports on the slicer, and it will allow you. It basically prints a support structure up to that overhang, and then when the printer goes to print there, it'll give it, I guess, the support it needs to actually print the layer. I could draw something, but I think there's two main types of supports you'll see. There's going to be branch supports and just normal supports, I guess. Branch supports or tree supports will, as Roman shows, look, more like a tree, and they're helpful for getting around weirder objects and use less filament getting there.
So this is the other type, so it's just like a rectangle that's very thin and it just goes up. So tree supports are a lot more efficient. They don't use so much material, and they're a lot easier to take off, and they don't break stuff because these can get in everywhere. The tree supports go right to that point and add pressure to it instead of just amassing.
Now you want to orient the piece in such a way that it takes as little support as possible, because you have to remove all those supports.
So this is tree supports. So you see how it's adding pressure to very specific places. Now imagine if that was just one giant box of supports. You'd have to clean it all off, and it wouldn't be clean. You'd probably end up breaking little tiny features along the way. So tree supports are good supports.
And you also, it's amazing at the angle that a printer can print. It can print at like I think it's a 23-degree angle was as successful as I've been, which is pretty sharp. So if you have something that has angles at like 10 degrees where you have to have supports, and then other parts that are at maybe 30 degrees that don't need supports, you can go into the slicer and tell it to get rid of certain supports while it keeps the supports you need. And that can save a lot of print time and a lot of filament.
Any more questions, comments, concerns?
So we have, the materials that we have available are PLA, which you mentioned, which is very stable and geometrically sound, but it's actually biodegradable. And that part will break. It'll work a few times, but it'll break. But it's cheap. And then we have nylon, and we have nylon that is impregnated with carbon fiber. We have polycarbonate, and we have polycarbonate that is impregnated with carbon fiber. And then he also mentioned TPU. TPU is you can make it, it's really soft, and depending on how thick your wall is, and what percentage infill, you can make it really soft. We made those star wheels. Did you notice Andy Martin is selling star wheels now? Yeah, I think I stole it from us. We make the star wheels out of TPU for catching a ball. And the difference between a round wheel that is compressible and the star wheel can be crushed all along.
So this right here, if you can see my mouse, what this guy's holding and flexing, that's not just a piece of plastic, that's TPU, so he's flexing it. It's not just made to be that shape. And you can see it looks like a failed print, or he stopped it, so you can actually see the infill there. So different types of that inner pattern will do different things, and different ways to print it will do different things. If the walls are facing one way, it'll flex a different way. So project of mine, I've been playing around with that, finding the best ways for things to flex, because we're making something that has to be a lot like a human, and certain parts of a human flex certain ways, and certain parts flex other ways. So we're playing with the actual orientation of the part and slicing it.
things about getting the print to stick is, one is your bed needs to be level. Some beds are auto leveling.
Reality lies to you. They say that it's auto leveling. It says specifically that it's auto leveling. You're doing it right there. You're manually hitting a button. It just goes up and down automatically. But there are printers that do the leveling completely automatically. It'll just probe the spot with the probe, and it says, "Oh, hey, this is that deviation from this point. Let's fix that." Like throughout.
So why would you have to level the bed?
No, like.
What's the purpose of leveling the bed?
Emma or Victor?
Louder, I can hear
Basically,
you.
when you're leveling the bed, you're making the bed in the same plane that the X and Y are in. So if the bed is tipped a little bit, it'll stick over here, but when it gets over here, it's not touching the plate, so it won't stick. So one of the first things you want to do is to print a brim or a skirt? Brim. Skirt.
No, brim. Is a skirt right up to it, or is
When you print a skirt, it does a line all the way around your outside, so it covers your whole area. And if that doesn't print evenly, your bed's not level.
So a difference between skirt and brim. Brim goes right up to your part. It actually helps with adhesion because it adds a bigger surface area. And a skirt just goes 3 layers around the outside, but it doesn't touch the part. So it is there just for purely leveling reasons. There's no real point behind it besides using filament and purging it and leveling reasons.
So if your skirt doesn't fit right, you know right away you got to stop. It's not going to work. And you can actually, one of these printers, you can see that the skirt is out. You can actually be adjusting the table as it's running.
So this printer, like I say, it says it's auto leveling. It's not. So me and Paul have a lot of experience. So when you're leveling a printer, you want to take a piece of paper and set it underneath and slowly raise the bed to the nozzle or lower it. But if you lowering it, then you've already messed up, or someone before you did. But with this, me and Paul just eyeballed it because over time you gain the sense of when the nozzle's right at the perfect height, and it's printing great. So it comes with experience being good at leveling stuff too. Your first time is not going to be perfect. So best thing to do is go around once on all 4 corners and then go around again and make sure everything's still level and make sure everything's where you want it to be. So a piece of paper is the right thickness for this to print correctly.
So this is a brand new printer. They took it out of the cardboard box 10 minutes before they started, and it's printing.
Reality's nice on that hand. They make good out-of-the-box 3D printers. Real good out-of-the-box 3D printers.
And this one, by the way, this is a free printer. So when we bought the water jet, we got rewards. And I didn't even know about it at the time. I got an email the other day. It says, you have $359 in rewards. You better spend it because it's going to expire. So I went on their site. This printer was, so we have $359.97 rewards. That was $359. So we still got to figure out where to spend 97 cents.
You could get maybe like a nozzle cleaner or something for that much.
Okay, before you all go away, I want you to write your name on these slips backwards and then fold it. Write your name backwards.
The letters backwards or just the letters out of order?
The letters out of order. That's a good question. The letters out of order backwards. So first and last name. First and last name.
Look at the infill. It's really interesting. It's pretty. Yeah. I do. I do too.
That might actually be
Yeah. Yeah.
I yanked it out of the boxes. When I picked it up, nobody would grab it, so I had to roam it. It's like a tape strip of granite. I I said, okay, I'll pick it up and you guys grab the box. I looked it up and then nobody.
Yeah, we didn't.
hold it there.
We were holding the box right there.
Man, that would take skill.
I could not find anything for 97 cents. Said we're gonna pull this up.